So today we're going to talk about the atomic structure. This is 4.1, starting unit 4. And some of this should be review for you guys. I'm hoping, but it probably hasn't been since like 7th grade that you've actually learned any of this information. Okay, so all matter is made up of atoms, right, or particles. And so this is the smallest unit of matter that forms elements. Okay. One atom is like 100 pictometers across its diameter. And then within one atom, it contains something called subatomic particles. Okay. And these are located within a single atom. So one atom of carbon contains neutrons, protons, and electrons, these subatomic particles. And within a neutron or within a proton, each one of those subatomic particles is made up of a quark. And I'm not going to get too in-depth in a quark because it's extremely deep in physics, the physics of chemistry, and even when I think about it, my brain starts to hurt because it's too much information and I can't understand it. So I'm not going to force you to understand it, but if you're interested in, definitely look it up. So a quark is just like an even smaller particle that makes up like a neutron or a proton. They're called elementary particles. And from what I found on the internet, just from a basic search, a proton contains 2 quarks. Electrons have 2, I believe, and neutrons possibly have 1, but I did not get a specific answer on that. And they have all these weird names to them, and so whatever scientist that found the quark, obviously like Star Wars, I think, or something similar to that. It's weird. It's weird. Scientists like to name things whatever they like. But I don't know much about elementary particles. But if you are interested, you can definitely look it up. I will not require you to know this information, so you don't have to write anything down about quarks. Just know that quarks are what makes up neutrons and protons and electrons. And protons, neutrons, and electrons are making up atoms. Atoms make up matter. Okay. And so back to subatomic particles, because we went too far into the physics of chemistry. Okay, so a proton is going to have a positive charge. And it typically has like, it's like 1.008 something. But it's going to have a mass of like 1. Okay. The location of protons is in the nucleus, okay? And a neutron is going to have no charge, or it's going to be neutral. It's also going to have mass, though. And so it doesn't contribute to the charge of the atom, it just contributes to the mass of an atom. And that is also located in the nucleus. And then we have electrons. And so electrons are going to have a negative charge. They don't have any mass, and they're located in the orbital clouds surrounding the nucleus. They are not in the nucleus. They are moving around protons and neutrons. And they kind of dictate what that atom will react with in the end. Okay. And like I said, all the mass is located in the nucleus. Remember, electrons have no mass, and so only protons and neutrons are contributing to the mass of that atom, which is located in the nucleus. And you can see the nucleus is in the middle, and then we have electrons that kind of orbit around the nucleus in different spins. Okay, so in order for an atom to be neutral, the amount of subatomic particles has to equal, which is these 2, meaning that they have no charge. They kind of balance each other out or cancel each other out. And then I want to talk about Coulombic attraction. And so Coulombic attraction is just the force between the positive and the negative of that atom that keeps electrons near the nucleus, okay? So if our nucleus is positive and our electrons so happen to be positive, what would happen as they rotate around that nucleus? Would they rotate around it or would they fly away? They would fly away, right? So if positive with positive, it repels. Think of it like a magnet. They repel one another. But if you put a positive to a negative side of a magnet, they come together. And so the forces of that positive nucleus is what keeps the electrons from completely flying away from the atom. Okay, it keeps it in orbit around it. Okay, and so we're gonna head into some of the periodic table stuff, and I have a laminated periodic table for everyone. And so if you pop into school for like an extracurricular activity, just stop in during the day and I can give you a periodic table, but I don't think that we'll need it until we get back before Thanksgiving. So I will give you one then. And so each one of the elements, and we have currently, as of the last time I looked this up, we have 118 of them in total. Each periodic table kind of changes a little bit year to year. New elements are added, mainly radioactive elements. And so not every periodic table is the same. Some periodic tables are going to have a lot of those newer elements missing. Some of them have different mass numbers. And so be patient. Don't fret if it's wrong. Generally, I fudge your calculations later in the year slightly by a couple decimal places just because there's a variation. And I'm not really sure why there's a variation. It's just whoever makes that table decides which one to pick. And it's kind of frustrating. But anyways, on the periodic table, there are symbols for each of the elements, okay? There is going to be typically a number on the top. It might not be in the middle. This is called the atomic number. This is the number of protons and number of electrons within that element, okay? Below that or near around that, we'll have like a letter or two. I don't think any of them has 3 letters. No. So 1 or 2 letters, which is the element's symbol. So for oxygen, for example, it's just a capital O. And then next we should have a full name of that element. Okay. And then on the bottom, typically there's going to be an atomic mass or atomic weight. Okay. This is just the number of protons and neutrons within that element. And so here's a little bit of information on how to calculate neutrons, protons, and electrons. And so like I said, the atomic number is the same number of protons and the same number of electrons. And so if you have an atomic number of 12, that means you have 12 protons and you also have 12 electrons. But you don't, not all the time, sometimes you do, but sometimes you have a different number of neutrons. And so this is where we have to do some calculations. And so you're going to use the mass, the atomic mass number or atomic weight to find how many protons. You're going to take the mass number minus the number of protons or electrons or atomic number. Remember, these are all the same value. Okay, so mass number minus one of these, which are all the same. That'll give you the number of neutrons within that element. Okay. That's it for 4.1. Do some of the practice problems on calculating protons, neutrons, and electrons. And I'll see you for 4.2.